Define the term resonant frequency power factor in series LCR circuit. So what is resonant frequency? So resonant frequency says in series LCR circuit, when inductive reactance is equals to capacitive reactance current is maximum. So this frequency is called resonant frequency. So what is the value of resonant frequency? Resonant frequency equals to how much? 1 by 2 pi root LC. That is resonant frequency. 1 by 2 pi root LC. That is resonant frequency. Then power factor. What is power factor? Power factor says कि power factor equals to cos theta equals to R by Z. So true power by apparent power, that is power factor, or this is R by Z, that is power factor. For what value power factor will be maximum? Power factor will be maximum in case of resonance. In case of resonance, XL equals to XC, so Z equals to R square plus XL minus XC whole square root over, as XL equals to XC, Z equals to R, so cos theta equals to R divided by Z is R, so that's why this is 1. So power factor is maximum. Power factor equals to maximum. Power factor is maximum, so this is the in case of resonance. So next second bit, moving to the second bit. So inductor value is given, capacitor value is given, resistor value is given, supplied voltage is given, find the impedance. Second bit. So inductance value is given. Inductance value equals to how much? 5 by pi Henry. Then capacitance is 50 by pi microfarad. Resistance equals to how much? Resistance equals to 400 ohm. Resistance equals to how much? 400 ohm. Supplied to voltage 140 sin 100 pi t. One forty sin 100 pi t. 140 sin 100 pi t. So what is the value of, so question is asked कि find impedance of the circuit. Impedance Z equals to R square plus XL minus XC whole square root over, that is the impedance. Impedance Z equals to how much? R square plus XL minus XC whole square root over, that is impedance. Then second bit, after impedance, RMS value of current. So what is the value of RMS current? IRMS equals to VRMS by Z. IRMS equals to VRMS by Z. 140 root 2 divided by Z. Z equals to R square plus XL minus XC whole square root over. That is RMS current. That is the RMS current. Second bit, draw the labeled circuit diagram step of transformer of 10 secondary to primary voltage with respect to the number of turns. Step of transformer. Step of transformer. For step of transformer, so this is the step of transformer. In case of step of transformer, E2 by E1 equals to N2 by N1 equals to I1 by I2. That is input AC. I1, number of turns N1. So load resistor RL. This is I2. This is N2. Step of transformer means, so this is V2. This is V1. Step of transformer means V2 is greater than V1. V2 by V1 is greater than 1. Transformer ratio V2 by V1 equals to N2 by N1. So N2 by N1 is greater than 1. N2 is greater than N1. Number of turns across secondary is greater than number of turns across primary. First step of transformer. Then what is the last bit? Last bit is given ki the number of turns in the primary and the secondary. So moving to this question, second bit question. Okay, moving to this question. So moving to this question, second bit question, the number of turns in the primary and the secondary coil of ideal transformer. So let's draw the circuit for the transformer. Suppose this is the transformer circuit diagram, and this is the primary and this is the secondary. This is the primary and this is the secondary. So this is the transformer arrangement. Number of turns in the primary equals to how much? 100. Number of turns in the secondary equals to 5000. Primary number of turns 100. Number of turns across secondary is 5000. 3.3 kilowatt power is given to the primary. 3.3 kilowatt power is given to the primary with 220 volt. 220 volt. So find the current in the primary. Find the current in the primary and output voltage and V2. Power formula equals to voltage into current. So current equals to power divided by voltage. Power by voltage is 3.3 kilowatt. 3.3 kilowatt. Power value equals to 3.3 kilowatt. 3.3 10 to the power 3 divided by V1. V1 is 220. So 3300 divided by 220. So after solving, so this equals to 30 divided by 2. So which is 15 ampere. So current in the primary equals to 15 ampere. current in the primary equals to 15 ampere, then V2, find the value of V2. So we know that V2 by V1 equals to how much? Equals to I1 by I2. V2 by V1 is I1 by I2. So, and N2 by N1. So we have to find value of V2. V2 divided by V1 equals to how much? V1 equals to V1 equals to 20. N2 equals to how much? N2 equals to 5000 divided by N1 equals to 100. So 0 0 cancel. 0 0 cancel. So V2 equals to how much? 50 into 220. So V2 equals to 22 into 5, 110, 11000. So this is equals to 11 kilovolt. V2 equals to 11 kilovolt. So what is the value of V2? V2 equals to 11 kilovolt. That is the voltage across secondary. That is the final answer.